First of all, thanks everyone for coming to our session here. So this is a little different for us. We're going to do something a little bit more on the technology side, but I think it's important. The world of clinical trials is changing, and the way you have to manage data in clinical trials is changing. So what I want to do is tee up this very important topic, and then I'm going to turn it over to my good partner here, Bruno, who's going to take you through some really cool information. As I just mentioned, the world of clinical trials is evolving really rapidly, and in conversations I've had with sponsors and CROs, a decreasing amount of data that's captured inside of a clinical trial actually comes from the traditional CRF and EDC platform. EDC is still important. You got to put the data somewhere, but more and more a clinical trial looks like vectors of data streaming in from disparate sources at incredibly high volumes at an incredible rate of speed. Think about things like lab data, think about things like sensors, think about things like, this wearable apps like my little Fitbit here, imaging files, et cetera. And you have to manage all that data, but more importantly in managing it, you have to be able to pull into what the environment for a controlled clinical trial looks like. That's not easy. And we at Medidata, in conjunction with SumoLogic, have built something we think is pretty cool in terms of how you manage that and how you think about this future world. So now I'm going to test my technology skills at clicking. There we go. So I think a lot of people know about, oh, did I skip one? Nope, that's it. Okay, so I think a lot of people know about our traditional platform, which is the Rave platform in EDC. What you may not know is that we've built lots and lots of extensions on top of that. There's one in particular that I wanted to highlight today because it really highlights the power of what SumoLogic does that you're hearing from Bruno, which is our SensorLink technology. So this is exactly what I've described. One in five of our trials now actually has some sort of additional device attached to it. That could be an ePro app with a mobile phone. That could be a sensor. It could be a consumer-grade sensor, like this Fitbit, or it could be a medical-grade patch or another device that we're wearing. So that data is then being relayed off of that device onto probably a phone or maybe a hotspot somewhere, and then into our clinical cloud. We use, a lot of you know, we use Amazon Web Services to actually capture all that data and stream it in. Just to give you an idea, and Matt, my product manager here, you can keep me honest, but the first time we did this, we did a trial with GSK, 5 patients. We just equipped them with some sensors. And we captured about 25 terabytes of data per patient or something like that. Yeah, which in that 5 days, we had captured more data from GSK than we had captured in the previous sort of 10 years that we've been working with GSK. So that's the order of magnitude the world is going to change. We have to make sense of all that data. So our job at Medidata is to bring that data in, to validate it, to make sure that what we expect to get is what we get, to make sure there are no gaps in the data. If there are gaps in the data, how can we explain them? To make sure there's compliance with the protocol and the device. Is the patient actually wearing the device? Is the patient actually syncing the device? Because you lose data if you don't sync the device. And then alerting our clients to the fact that you may have to take action, alerting the site that you may need to contact this patient. We use the SumoLogic technology to help us do that. So you're going to hear from Bruno how their technology actually powers our clinical cloud platform to be able to pull data in. And I think I have one more picture here that talks about how we can actually pull data in and using this technology, validate that we've gotten the right data, it's attributed to the right patients in the right trial, and then make sure that when all is said and done, when you go to package that data up and put it into a submission or do analysis on it, we can stand behind that data. That is just one of the uses of SumoLogic. You're going to hear a lot about our other technology in this conference. Tomorrow morning in the keynote, you hear about strategic monitoring. Same concept, the ability to actually underpin that, validate, and make sure we're auditing data. A very important part of the platform, and these guys help us tremendously do that. So that's going to be it for me. I'm going to see you guys in about an hour at the keynote. What I want to do now, though, is introduce Bruno. So Bruno, you are, I'm going to say this right, you are co-founder and also VP of Product and Strategy at SumoLogic.
Right,
so let's give a warm welcome to my friend Bruno here. Thank you.
Thank you.
Yeah.
Great. All right. Well, thank you all for spending a few minutes with us today. We're going to go a little bit up, zoom out, so that we can go a little bit deeper into the topic of what we do and what it means to run traditional industries in digital ways. So SumoLogic, for most of you probably haven't heard of us, I wanted to share a little bit about who we are and what we do. So we are a machine data analytics platform. And machine data, we'll talk a little bit about that in a second, are things that are generated by modern applications and infrastructure, cloud infrastructure, and other things like that. We service customers, Global 2000, across a variety of industries, including many in healthcare. We have built our service to scale to be able to handle the tremendous amount of data that's generated by platforms like Medidata's platform as they serve their customers. So just to illustrate that, we analyze about 100 petabytes of data every single day, which is about 400 trillion records. And our customers, about 2,000 of them, run 30 million queries every single day to analyze the data they send us. So every industry today is getting either disrupted or shaped by digitization. Just about every industry, every company in every industry today is a software company. Most industries are affected by this trend, and enterprises are trying to adapt and serve their customers better through digital means, which means that they're writing software. They're writing software to improve the services and products that they offer to their customers, just like Medidata is to you, right? They're building a software technology that helps you run your business better. So that's given a rise to what we call a modern application. In order to serve customers when they need it, quickly, to adapt, to differentiate in your industries, people are building applications that look very different and behave very differently than the traditional data center three-tier applications that you might have interfaced in the last decade with. Most of these applications leverage a modern technology stack that includes things like cloud services like Amazon and Azure and Google Compute Cloud. And why is that? That's because they provide a far better agility to enterprises to deliver products and services to their customers. So you can, instead of having to procure 5,000 servers to power an application and put them into your data center, you can buy an hour worth of time on 5,000 computers and spend the amount of money you would have spent to buy a single computer, right? So it provides companies much better agility and a much better speed to delivering products. These applications also have a very different life cycle. They are typically built by development operations teams, DevOps, commonly known, and using agile development processes that allow them to ship new code into production multiple times a day, which means there's a lot of change and into these applications, and you have to be very careful how you manage that change so that the end customer isn't impacted. Last but not least is these applications also have modern type architectures, which both enable companies like Medidata and SumoLogic and others to deliver more stable, more reliable products, but they also bring forward a complexity because these applications are far more distributed. Understanding where the data is, how data flows through these applications is more complicated, but it's worth the trouble because you ultimately produce a much better product. So since these applications are typically serving customers, and in this case in healthcare and pharma, a lot of the data that flows through these applications is really, really sensitive. So it's private information. A lot of that data is under regulatory scrutiny, and platforms like Medidata's have to take great care to ensure that data that's flowing from SATA through a SensorLink application or other parts of the Medidata application set is kept in a compliant way, and that the tooling that they use to ensure this, one of which is SumoLogic, has to be also very secured and compliant with a variety of regulations. So we've spent a lot of time over the last 8-9 years building security into our service. So we, for example, have a HIPAA and high-tech attestation, which is renewed every year. We sign BAAs with our healthcare customers. We are also a PCI, payment card industry, provider level 1 company, which means that if our customers are retailers and they process credit cards on their retail site, if those credit card numbers leak into their logs, SumoLogic is actually authorized to hold them. So the entire perimeter of the modern application is kept in a secure and compliant way so that you can do your business without having to worry about that at every step of the way. And there's a slew of other regulations that we also support for other industries, including things like global, like EU Privacy Shield and the upcoming GDPR regulation in Europe, which will bring another level of scrutiny to security of data sets that are flowing through modern applications. So, spend a little bit of time talking about what's this machine data business. Machine data, as I said a little bit about at the beginning, is data that's generated by applications like Medidata, set of applications that you used. So every time a piece of data is generated by a patient that flows through the SensorLink application and through the rest of the platform of Medidata, that one piece of data, the flow of that data, generates probably several tens of thousands of another sets of data, right? Bits of data that trace how that piece of information has flowed from a sensor on somebody's wrist all the way to being stored so that you can actually leverage this data in your clinical trials. So it's really voluminous. It comes in form of log messages, audit messages generated by applications and infrastructure. It could be metrics, things that are that measure things like CPU consumption, memory, and I/O, and things like that. It could be events that might be things like, okay, we just deployed a new version of SensorLink code, and we need to know that in order to measure how that new code is behaving and performing versus the old code. Or it could be things like context that say things like, okay, we are monitoring security and somebody's trying to scan or SQL injection attack one of our nodes, one of our servers. Should we worry about it? Maybe that machine was patched. Knowing that information helps you make decisions downstream and what to do. So this data is highly unstructured. This data has a very, very high rate of change. Every time development team from Medidata submits new code into production, that code usually comes with new records of data. And since it's unstructured, the downstream tool like SumoLogic has to be able to deal with that data without knowing that it's coming and without knowing what is the structure of this data. And it also comes in huge volume, right? Any one of these records, many of our customers send us tens of terabytes of data per day, and that equates to multiple tens of billions of records every single day. So all of this data is then aggregated and needs to be used to ensure stability and security of the application that you ultimately use on the other end. So on top of all of these three characteristics, this is what that data looks like. Right? So how do you take this, an example of a log line, this is actually one of ours, and make sense of it, right? And new ones of these occur and appear in the data set every single day. This happens to say that we have a failure, like it's an error generated somewhere in the code that has caused a service to fail and has caused a whole host to restart, right? And you find that by having to understand this sort of jumble of strings, parse those values out to actually make sense out of it. So in this type of data is used across a variety of use cases. And I wanted to spend some time today and walk you through some use cases that Medidata uses SumoLogic for to deliver the applications to you that you use on a daily basis in your clinical trials. So first and foremost, there is the development and operations and IT operations use case where they are ensuring that you're getting the SLAs that you require from them, that the data has its integrity, that it's fast, that it gets from A to B in a short enough time so that you can use it in your trials. They also use SumoLogic to ensure that this data is treated in a compliant way, that their application is secure, that it can defend their application against the bad actors out there. They also use it for customer support and customer success, as well as for other types of business analytics. More and more so these days, digital enterprises are running their business on the machine data, which is the exhaust of a digital business, right? It used to be that a data warehouse is the thing that you run your business on, that you decide, you predetermine what data you're going to need, then you communicate to your developers, they build that data in, they build a data warehouse, then they generate that data, and ultimately you get a dashboard. These days, more and more companies are going straight to the output of their machines and infrastructure to measure that business outcome, right? So you skip all of that costly and lengthy process of transforming that data to get the benefit. Here you can tap right into live off of your applications and infrastructure. So we'll walk through a few of these examples. So you saw this, right? This is what it looks like when it's generated, and this is what it looks like once we get it and we process it and we massage it into a shape that can actually give you business value. So this is an example of a operational monitoring dashboard that Medidata uses on a daily basis to ensure that the application that you use performs well, right? It monitors number of requests that are coming from you as you're interfacing with these applications. It's monitoring for errors. It's monitoring for things like how long is the response time. They have SLAs they want to maintain, and they're measuring exactly how often is our response time to our end users outside of this boundary that we want to keep and deliver to them, right? And so this runs in real time, manages all of this data that comes in from all of their application and infrastructure, and gives them real-time views of this and provides them with alerts and other things so that they can usually solve problems in their applications before you even notice that there is a problem in the applications as you're using it. Sometimes these apps are underpinned by platforms. So what I'm told, because this is a metadata dashboard as well, is that the platform service that is running underneath the variety of applications like SensorLink and Rave and others, that platform itself can impact how the application is behaving that you're using in your clinical trials. So the full stack is monitored. Oftentimes, you can monitor the underlying platform and detect when something starts to go sideways, and you can preempt issues downstream in the application capabilities that customers end up using. So, and this could actually, platform-level services can impact not just one application, they can impact all of the applications. So monitoring the full stack of the application, the API layers and all of that is very important. So, and it doesn't really stop there. So I talked a little bit about earlier how this data can be used for business intelligence, for improving of your application. So at Medidata, this is one of the examples where they're trying to understand the usage of their applications and technologies, and they use that data to improve their products and services, right? They understand what are people doing in the applications, how are the new features that they ship behaving, are customers able to find them, are they performing well, are they useful, and they use this data on a continuous basis to improve their applications that they serve to you. We at SumoLogic do the same thing. We practically run our entire business on the output of our application. Like we have product managers like Matt here and others who live and breathe by this data and constantly observe what our customers doing in order to deliver better products and services to their customers. So most of our Global 2000 customers do this as well. So, and then I'm going to shift gears a little bit and talk about security. So security is in the news every day today, and how do you ensure that everything that you do in your IT, that your infrastructure is in good shape, that your employees who run these services are doing the right thing? How do you ensure that the users who are interfacing with these applications are doing the right thing to make sure that everything is kept safely and securely? So this particular example here is looking at the infrastructure layer. So you know, in the world of when you interface with the metadata application, the communication between you and the application is encrypted. But there are different levels of encryption and different protocols that are being used and ones that are being sunset. For example, this is monitoring a TLS encryption layer between your browser and the metadata application to minimize the use of TLS 1.0 and 1.1. Why? Because there are newer standards, richer and more robust encryption technologies that metadata wants you to use as you interface with the application to ensure the security of that link between you and the application, right? So at some point, this will be zero. There'll be nothing on this dashboard. And at that point, you will all be on a next generation security layer. But you can't stop at infrastructure. Oftentimes, infrastructure is doing just fine, but oftentimes the user, the actual human, is the weakest link. So one of the things that we ship, and this is actually one of our dashboards, so I didn't share Medidata's version, is that you need to understand when a user connects to your application, is this the legitimate user that you think they are? and do they have a compromise associated with their account? So what we do is we embed a premier threat intelligence data feed, and this is a little bit esoteric, but I'll tell you anyway what it is. There's a consortium of security companies out there that monitor the behavior of IP addresses, usernames, domain names, and all these things out on the internet to detect indicators of compromise. They then package all of that data, that metadata about IP addresses and users, and they can then provide it to technologies like ours. And we embed this technology into SumoLogic in real time so that Medidata can do the following. They can take all of the logs and all of the activity that they capture in their machine data, your user IDs, IP addresses, all the things that happen inside of their environment, and correlate that with this known indicators of compromised data set. So what they can do with that is they can tell, hey, there's a user that is a known user of metadata application that is coming from an IP address that is known to have been compromised. Why is that important? Because when somebody's machine has been compromised, the compromise can actually do things like use key logging. They can do screen scraping, all kinds of things that could ultimately lead to data leakage and other types of problems. So this gives you a real-time view so that you can actually intercept that communication path, terminate accounts, block accounts, do all kinds of things that help you ensure that the user behavior is within compliance that you need to be in. And then also compliance. Compliance is something that I'm sure many of you are very familiar with. When you run your business and go through your business processes, if you are under the purview of HIPAA or PCI or some other regulation like Sarbanes-Oxley, you get audited. Your companies get audited, your IT infrastructure gets audited, and you need to prove not only to your internal auditors, but also to the external auditors, essentially to learn the license to do business in the industry, that you are handling your applications and data in a compliant way. This is an example. This is our own. It's all masked. All of the private information is masked, but we have to be PCI compliant to serve financial services customers. And this particular dashboard that we ship out of the box helps us prove to our auditors that we are doing the right set of things under the hood. So those are some examples on how we, Medidata and SumoLogic, help deliver secure and performant applications to you. And I know that this is a little bit more in the IT domain, but I'm happy to answer any questions that you have about this kind of stuff that you might have within your enterprises. Go ahead. Oh, there's a mic, I think. Right here.
Yeah, hold on.
I mean, so one of the things which you mentioned, what I was more interested was in, the variable technologies, and is there any use case which is implemented using
Absolutely.
variable technologies, integrating with the Medidata platforms, and how some of the, I mean, if it's a variable technology, right, you need to authenticate who is this person.
Yep.
What kind of technologies, any biometrics which is being used, and how that is being authenticated, saying the data is coming from the right user.
Yep.
And,
That's a good question. So the wearable technologies that Medidata uses in the SensorLink communicate to the rest of the Medidata application through a set of APIs and SDKs, right? So what they do is they capture that traffic at every step of the way as the device syncs and starts sending data. Once it hits the boundary, the APIs log all of the information about that traffic. That usually contains things like what happened, when it happened, who did this happen with. And that type of data can be used to both ensure that the data is flowing, that the data integrity is right. It can be used to detect whether the user is the same user that you've had, and you can do this by monitoring things like geolocation of a device. You can do this by baselining the behavior of a specific user and detecting changes from that baseline. There's a variety of techniques that can be applied to this. Some of the metadata developers probably know more about specifically what they use to ensure authentication, but the amount of information that's captured, it captures every single step of the way in this data chain that when it comes from a device all the way to the metadata's backend.
And since these are wearable devices, right? I mean, it has to connect through their local Wi-Fi or whatever.
That's right.
How is it being ensured that somebody is not hacking into these connections and spoofing data? Or I mean, the reason I'm asking is like having worked a little bit with some of these wearable technologies, a lot of emphasis is being placed on exactly the security of the data and the authenticity of it.
Yeah, no, that's fair. All of this data flows obviously through the local access point, whatever that might be, wired or wireless, or maybe in some cases through a cellular network, right? And that data comes through a known set of APIs to which the device is coded to communicate. And so that channel usually is encrypted, right? And I don't know about every device that metadata might support, how that works, but the communication between the device and the backend is through a known set of APIs, which have a pinch point where you can capture the information about that transaction, where you can control the encryption level and encrypted communication. Now, you can't control physically a human and whether they can give that device to somebody else. But there are heuristics and anomaly detection techniques that you can apply to discern whether this user is the right user or not the right user, right? So, we can maybe go into a level of detail later after we are done with the presentation to understand how that works at a far deeper level. We just spent some time downstairs on 5th floor with the metadata team where they talked about this. Other questions? No? Okay. Thank you very much.